All right, if we look here at number 25, it says that Stephen wants to buy a bicycle that costs $565. He has no money in the account to start, but he's going to deposit $30 each week, essentially. But then the catch is that he actually owes his sister $65, so he has to pay her back before he can buy his bicycle. So if we start thinking about this kind of in slope-intercept form, we're going to say y equals, that's how much money he has in his account. He's going to deposit $30 every week, so if x is the number of weeks, so it's 30 times x. But then we have to take money out of that account. We have to subtract $65 from that account once it's in there to pay his sister back. Okay, so the model here is showing us that it's $30 per week minus the $65 that he owes his sister. And we want to know, when is he going to have enough to buy the bicycle? In other words, when will the amount in the account y be $565? And so we go ahead and plug that in for y, and now I just solve for x. So I go ahead and add the 65 to each side. That gives me a 630. And I'm going to divide each side by the 30. And it looks like I get an x value of 21. So 21 weeks. Okay? If I look at the next one, it says John and two friends are going out for pizza for lunch. They split one pizza and 3 large drinks. The pizza costs $12. They spend a total of $16.95, and we want to find the cost of 1 large drink. Seems a little odd that the two that they're, oh, never mind. It's 3 friends, so it's 3 people, 3 large drinks. So really, we just write an equation here. We say, okay, x we're going to say is the price of the drinks. And so when I write my equation, it's $12 for the pizza plus 3 of the large drinks, and the total equals the $16.95. Okay? And now from here, I'm just going to solve this thing. So I'm going to go ahead and subtract the 12 from each side. So I get 3x equals, looks like a 4.95. And now I have to divide that by the 3. And I'm going to let my calculator do the work on this one. Looks like I get 1.65, so $1.65. So each of the drinks is going to cost $1.65. That's it. So just writing a linear equation and solving that linear equation. All right? The next one, it says a copy center offers its customers 2 different pricing plans for black and white photocopies of 8.5 by 11-inch pages. Customers can either pay 8 cents per page or $7.50 for a discount card that lowers the cost to 5 cents per page. And we want to write and solve an equation to find the number of copies for which the cost of each plan is the same. All right. So again, this is essentially a system of equations where one of the equations we're just getting charged a straight fee, so it's just y equals, that's the amount I pay is going to be 0.08 per page, which I'll call x, versus I could pay a little bit less per page, so 0.05 per page, plus the $7.50 membership fee. Okay, and so what we have here is a system of equations that needs to be solved. I'm going to solve it by substitution because I already have one of my variables by itself, so y equals this guy right here, so I'm going to plug that in for y in my second equation. Okay, so it becomes this, it becomes 0.08x equals 0.05x plus the 750. All right, and now I got to get my x's on the same side. I subtract the 0.05x from each side. That gives me a 0.03x equals the 750. And now I'm going to divide each side. Whoops. Almost put that 3 in the wrong spot. And again, I'm just going to use my calculator to help me out on this one. So I got to do the 750 divided by the 0.03. And it looks like 250 pages is what I would have to print. Okay. And I'm not quite done. It does ask for the number of photocopies here. for which the cost is the same. Out of curiosity, we could plug this back in and see what the cost would be, and the cost happens to be $20 at that point. But really it's 250 photocopies is really the thing we were after here. We didn't necessarily have to find the price, but it's nice to kind of complete that in terms of the Y value that we found. Okay. The next one here, it says solve for x, so I just have to get x by itself. And so when I look at this guy, it's all variables here. I just have to move this over to the other side, so I'm going to subtract the a from each side. Just working on getting x by itself. Here the a's cancel, so I get a negative q equals s times x. And now I have to divide by the s value. So I find out that x equals, I just leave it as a fraction, it's negative q over s. And that's it. Alright. This one, it says in an automobile factory, 1,849 parts are made in 4 hours. What is the average rate of at which parts are made per hour? Really, it's just asking for kind of a rate of change here. It's like slope. It's saying that there are 1,849 parts per 4 hours, so over 4. And then really, it's just a matter of reducing this thing or dividing this thing in order to figure this out. It ends up being 462.25 parts per hour. So we're just kind of converting that to be per hour instead of per 4 hours, is the way it was written originally. Next one, total cost to rent a boat is $16 times the number of hours the boat is used. How long can you rent a boat for if you have $224? So again, we're going to say y equals, that's the cost of renting the boat. It's 16 times the number of hours, which I'll call x. And then really it's just saying, okay, well, what if I have $224? In other words, if I plug a 224 in for y, how many hours is that going to buy me? I just have to solve this thing for x. So I divide each side by the 16, and I find out that x equals 14, so I can rent this thing for 14 hours. This one, a car travels 180 miles in 7 hours. Car A travels 180 miles in 7 hours. Car B travels 350 miles in 4 hours. Car C travels 584 miles in 12 hours. Which car has the fastest average speed? So again, this is just rate of change, and I'm just going to reduce this. So let's see if I want the speed of car A. I'll just say A is 180 over 7 is essentially the speed. Car B, the speed is 350 miles over 4. And car C is 584 miles over 15. But then, in terms of comparing these, it's hard to compare these when I have a bunch of different fractions, a bunch of different denominators. What I do is I go ahead and just plug each of these into my calculator so that I can write them all as decimals. And so car A is going at 25.71 miles per hour. Car B is moving at 87.5 miles per hour. And car C, 584 divided by 15, is moving at 38.93 miles per hour. So it looks like car B is moving the fastest because it's got the highest speed per hour. And again, we're just converting this into units that make sense in terms of comparison. All right? For these guys, each of these are set up as proportions, so I'm just going to cross multiply and solve. Remember, when you have two fractions equal to each other, you take one numerator times the other denominator. So here I would do the 15 times the 4, which gives me a 60. And then I say that equals, now I do the other numerator times the other denominator, the negative 5n times 2, which gives me a negative 10n. And now I solve this thing. I'm going to divide each side by the negative 10. And when I do that, it ends up giving me an n equals negative 6. And that's it. Okay. Next one's the same kind of thing. I take the 3 times the negative 10a, that's a negative 30a. And then I do the 8 times the negative 4a minus 1. And you can go ahead and distribute that in your head. I just am going to go ahead and write it out this way and now distribute the 8 just to show a little bit more work here. And to make sure we don't make any silly mistakes. Now I'm going to get the a values on the same side, so I'm going to add that 32a to each side. So I end up with 2a equals the negative 8, and now I divide each side by the 2. Okay, so just solving the equations. 2 fractions, you solve using cross multiplication. So I get a equals a negative 4. Next one, once again, same kind of thing. Again, I'm going to write it out to make sure I don't make any mistakes. I do the 3 times the 4w plus 6. And then I do the w plus 14 times the 4, or 4 times the w plus 14. But when I cross multiply, I set those things equal to one another. Now I use my distributive property. That's a 12w plus 18. Here that's a 4w plus, sorry, almost read a 56. And now from here I have to get the w's on the same side, so I'm going to go ahead and subtract the 4w. And you should always move the variables first, and I always move the smaller of the 2 variables so I don't have to deal with negatives as much. So 8w plus 18 equals the 56. And now I'm going to subtract the 56 from each side, or sorry, the 18 from each side, moving it over towards the 50, where the 56 is. Looks like that gives me a 48. And now I'm going to divide. Oh, sorry, not a 48, a 38. I missed a... Oh my goodness. That is the wrong color there, Mr. Jansen. Let me try again. 38, there we go. And now I divide each side by the 8. Okay? And from here, I'm just going to go ahead and leave this as a fraction. I'm going to say w equals... It says 38 over 8, but I want to reduce that. I can divide each of those by 2, so this becomes a 19 over 4. And that's how I'm going to leave my answer, just 19 over 4. And that's it. If I look at the next one, it says a tree casts a shadow 10 feet long. A boy standing next to the tree casts a 2.5 foot long shadow. The triangle shown at the tree is similar to the triangle shown at the boy. Really, this is just a thing where we have similar figures. Remember, similar triangles, we set these up in terms of proportions. And it says the boy is 5 feet tall. It's the only thing that, the only piece of information they give us that's not labeled on the picture. This is 5 feet right here, is the height of this kid. Okay? And so, as I set this thing up, really, oh boy. The thing I'm trying to find here is the height of the tree, which I'll call x. And so I just have to be consistent in terms of the way I do this. So I'm going to do the shadow over the shadow. So the shadow of the boy over the shadow of the tree equals then the height of the boy over the height of the tree. And as long as I'm consistent in terms of setting those up, I can cross multiply and solve this proportion. Okay? So 5 times 10 gives me the 50. 2.5 times x gives me a 2.5x. And now I'm going to go ahead and solve this thing for x, so I'm going to divide each side by the 2.5. So when I do that, I find out that x equals, again, just plug it into your calculator, let it do a little bit of this work for us. It gives me a 20, so it's 20 feet for the height of the tree. Okay? This one, it asks what percent of 100 is 78? And so we're looking for a percentage here. So if I want to know what percent that is, really I just put one over the other and say, okay, 78 over 100, which is a little silly, but that gives me a 0.78. And then when I convert it to a percentage, as you multiply by 100, it's 78%. Okay, 100 is probably not the best example to use here. Sorry about that. The next one, it says 125% of what number equals this. And when I do percentages, I just take the percent times the number that I'm looking for. So it's the percent times whatever number I'm trying to find equals whatever the percent of that number is. And so with this one, I take the percent, which I always write as a decimal, it's 1.25, times the number I'm looking for, which is unknown at this point, and I know that it equals 264. In other words, 264 is the percent of what number? Well, now I have to solve this thing, so I'm going to divide each side by the 1.25. The other option is the old is over of equals percent over 100, which I'll do next real quickly. But I just have to divide this by the 1.25. All right? And so I find out that x equals 211.2. All right? The other option is the good old is over of equals percent over 100. And so when you look at this thing, again, is over of equals percent over 100. See, the percent is easy. That's the 125, and that goes over the 100. And then the is and the of, it says of what, and is 264, so the 264 goes up here. The of what means I don't know what it is. I call it x. And now I cross multiply and solve. I get 125 equals 125x equals 26400. And now I divide each side by the 125. And when I do that, I find out that x equals, of course, the same thing, the 211.2. Okay, so two ways to do it. The is over of is a little bit more work, but it's less to think about. Using just percentages to multiply is a little bit less work in terms of what you actually have to write down and do, but it's more work in terms of your thinking, in terms of what you have to think about. Okay. The next one, it says Laura is buying a new table for her dining room. She finds one that she likes, and she estimates that the tabletop measures 7 feet by 4 feet. The tabletop actually measures 8 feet by 5 feet. What is the percent error in the estimated area of the table? And so really I just need to find the area of each. So this one, the area of a rectangle is just length times width. So the area that she estimated was 7 times 4, which is 28 square feet. And then the actual area of this thing is 8 by 5, which we'll say is 40 square feet. And so the percent error is how far off she is. And so when you think about it, you know, she calculated at 28. The actual area is 40. So in other words, the how far off she is, we have to subtract. She's actually off by 12. And the common mistake here is students just find the percentage of 28 over 40. Well, no, we want the difference here. And so she's off by 12 square feet. So then I put the 12 over the 40 and calculate that percentage. Okay? And so when I calculate that percentage, I just divide. That's a 0.3. And then as a percent, that's 30%. So she has a 30% margin of error because she was off by 30%. Okay? The next one, Glenn is looking into buying a piece of land. He estimates that the land measures 100 yards by 850 yards. The land is actually 140 by 940. And we want to find the percent error once again. And so I just find the area of each. So his estimate was 100 by 850. The actual area was 140 by 940. And so I just calculate each of these. This one is 85,000, and then that's square yards. This one, if I punch into my calculator, 131,600, and again that's square yards. And so again I want to find out how far off he is, so I'm actually going to subtract these values. And so when I subtract these two values, I find out that he was off by 46,600 square yards. Well, I have to divide that. I have to find the percentage of that over my actual value. And so I just divide these things, and then I'm just going to convert it to a percentage. And so I get 0.3541 approximately, which is about 35.41%. Okay? If I look at the next couple, it just says to solve each inequality in graph. And I solve inequalities the same way I solve equations. I undo order of operations. The only thing I have to remember is if I multiply or divide by a negative, I have to flip the inequality sign. So if I look at this first one, I divide each side by a negative 8, which gives me x. Over here, I get a negative 6. But because I divided by a negative, I have to flip the inequality sign. So now I have x is greater than the negative 6, which I go ahead and throw that down on my graph. I've got negative 6 here. And I just put a couple values down. When we're looking at this thing, because there's no equal to condition, I use an open dot, and then greater than means I'm going to shade to the right here. Okay? The next one, same kind of thing. I'm going to go ahead and use my distributive property. So I'm going to distribute that 3. That gives me a 6 minus 3x. It's greater than 9. I'm going to subtract the 6 from each side, just like I would if I was solving an equation. And now I'm going to divide each side by that negative 3. Because I'm dividing by a negative, I have to flip the inequality sign. So now what I end up with is x is less than, almost forgot to flip the inequality sign, less than a negative 1. Okay? And again, as I plot this on my number line, I put down the negative 1, maybe a 0, maybe a negative 2. Let me scoot this guy off to the side a little bit to get him out of the way. So I got x was less than a negative 1. I use an open dot because there's no equal to condition again, and I shade everything to the left because I want to be less than that value. Okay? Next one, same kind of thing. Let me section these off a little bit so we're not running into the previous example. I'm going to go ahead and use my distributive property, so I'm going to distribute that 2. Gives me the 2x minus 8. Now I have to get the variables on the same side, just like I do with an equation. I subtract the 2x. And now I'm going to finish solving this thing by adding the 6. And lastly, I'm going to end up dividing by that 2. So now I divide each side by the 2. And once I do that, I find out that x is going to be less than or equal to the negative 1. And notice the sign doesn't change because I didn't multiply or divide by a negative. So now as I plot this on my number line, negative 1, 0, maybe a negative 2. This time, because there's an equal to condition, I'm going to use a closed dot. So a closed dot for this one. And less than, it means I shade everything to the left. Okay? The next one, same kind of thing. I'm going to go ahead and distribute. So I'm going to distribute this negative 3. So I've got a negative 3x plus 6. And now I'm going to combine like terms, the negative 3x and the 7x. Because they're on the same side, I don't move them. I just combine them because they're already on the same side of the inequality. And now I solve this thing. I'm going to subtract the 6 from each side. And then divide by the 4. So I got x is less than 4, and now I graph this thing. Again, 4, maybe 5, maybe 3. There's no equal to condition, so I use an open dot, and I shade everything to the left because it's less than. Next one, same kind of thing. I'm going to go ahead and subtract the 16 from each side. So I've got a negative 7x is greater than or equal to, looks like a 21. And now I divide each side by the negative 7. Because I'm dividing by a negative, I have to flip the inequality sign. So that's going to be x is less than or equal to a negative 3. And then again, as I graph this thing, there's an equal to condition, so I use a closed dot. Less than, I shade everything to the left. This one, the second, just like in equations, the second I see all those fractions, I want to get rid of them, and I can always get rid of fractions by multiplying through by the common denominator. So the common denominator here is 2. Whatever I do to one side, I have to do the other side. So now it's just my distributive property. I'm going to get rid of all the fractions. So here that gives me a 3x minus 6 is less than, this gives me a 2x plus 5 minus x. And now I'm combining some like terms over here. That gives me an x plus 5. Now to get my variables on the same side, I'm going to subtract the x. So I get 2x minus 6 is less than a 5. I'm going to add the 6 over to the other side. And then divide by the 2. Once again, I'm just going to leave this as an improper fraction. I'm just going to say x is less than an 11 halves. And when I graph that, I just have to understand that 11 halves is actually 5 1/2. So that means up here I would have 6 and down here I would have 5. So I just want to kind of give that context on my number line. There's no equal to condition, so it's an open dot. Shade everything to the left because it's less than. Okay?